We are going to talk about forces of deformation. Forces of deformation is basically the idea of stress versus strain. So we're going to take a look at stress and strain and see how they're different, but also how they correlate with each other. So let's talk about stress first. Stress is defined as deformative tensile force or dimension of force per unit area. A very simple example of this can be seen by using an iron wire. If you were to pull on each end of an iron wire, there would be stress at the center of that wire, and that type of stress is tensile stress. Now, strain, on the other hand, is a relative change in size or shape. Many might add to that definition that strain is a relative change in size or shape due to externally applied forces. So we'll use the wire as an example again. You can calculate the strain on a wire by dividing the amount of increase by the original length of the wire. So basically, stress is to force as strain is to deformation. And these are two completely different concepts, yet they correlate, as we know that Hooke's law states that stress is directly proportional to strain. So that's the basic concept behind forces of deformation.
Today I am demonstrating shear stress. Shear stress is a combination of two oppositely directed forces along the parallel lines of action. Here is an example. As you can see, the line is being pulled in opposite directions. The back end of the line is connected to the reel, the front end is connected to the hook. As the line is being pulled in both ends, tension is applied in both directions. If any perpendicular force is applied on the parallel line, shear stress will occur. Doing this would cause the line to bend.
Now we're going to talk about volume stress. Volume stress is the stress that causes bulk deformation. Volume stress is still deformative force per unit area, but it is a little different, and it's different in the way that it acts upon the entire area of a surface. Now, because of this, volume stress is many times defined as a change in pressure acting on an object's volume. A good example would be to take some sort of object, and if you were to submerge this object in water, the volume would change, and you might refer to that as deforming. So change or deform, and it's not a permanent change, however, which is why there is no elastic limit or ultimate strength in volume stress.